Recording started. We're ready.
Okay, sir, I haven't seen you here before. I mean, I think I may have seen you virtually. Why don't you tell us who you are?
I'm Kevin Hines, KO4 CTL. I've been licensed about 3 years, just haven't done very much. Excited to learn from everybody, anybody.
Welcome, Kevin. Why don't we go ahead and introduce ourselves? I'm Rick, K4HM, the president. And let's see, we'll pass the microphone around and
Mike, K4RKO.
Dennis, KG4UPT.
I'm Ken, KQ4EPK.
David, Whiskey Delta 3 Oscar.
Carl, I'm a guest, KF4UBE.
Lauren, WD4FMG.
Daryl, WW4F.
Gene, K4GNE.
David, KO4RNT.
Robert, W4BNO.
John, K5HTZ.
Malin, N4EG.
Tom, KG4BIZ.
Armin, WA1UQO. Dan, N4DOB.
Bob, KG4ZIK. I'm Brock, WF4J. I'll give it to the cameraman.
Jim, W4PKR.
and now the prime minister of the club.
The camera operator, he's the camera operator. I'm the system operator. Bruce, W4BRU. I guess we got to do the people online.
Okay, how about the people online? I guess we see your names up there. I don't know how to do that in a serial way.
Scott, go first.
Go ahead, Ken.
Scott, KO4UOR.
JB Edwards. Edmund, I'm sorry.
Yes, JB, N4NQI.
Okay, Ronnie.
Yeah, Ronnie, WU4G.
Okay, we got John.
This is John, QC.
Oh, we had two Johns. John in the blue shirt go first, and then we'll come back to the other John. I'm sorry.
John, KE4THI.
Okay, John in the nice pretty vest.
Haven't been called pretty before today, but it is. KX4QC, John.
Okay, Dave White.
Dave, W4IIA.
Okay, Patrick. Patrick, unmute.
Patrick, KE4BUO.
Okay, Deb.
Debbie Howard, I'm KO4JGW, it says right there.
Okay. The other John that we haven't had, how's that? W4ZAK. Unmute first. Yeah.
This is John, W4ZAK, in a blue shirt.
In a blue shirt. Okay. Let's go. Bill and Judy, if you're both there.
Yep, Bill, N4WLC.
Judy, N4JDI.
Melina.
Melanie,
Melanie, yeah.
KN4CSY.
Yeah. Excuse me. David.
I'm assuming me, David Elkins, KN4RQ, and good evening.
Yes. W4RQ or RYQ.
Whiskey for Romeo Yankee, Quebec. This is Doc Ellis.
Okay.
And,
and
I'm still at work up in.
All right. And W1OLE.
Good evening, Nathaniel, W1OLE.
Okay. And I'm Ken Leidner, WV0L.
Okay, thank you, Ken. Were any of the people, virtual people new or visitors? Or is everyone a member? Okay. All right, well.
I am not a member.
Okay, and you look like the Grand Canyon from here, but
yeah.
Well, I'm driving right now, so you wouldn't be able to see me anyway. But my name's Nathaniel. I live in Ohio, and I have quite a few good friends in the Richmond area. Doc and Bill and Judy among them, and both of the Davids there. I just happen to be driving right now, and Bill said, "Hey, it's time for the RARC meeting." I said, "Well, send me a link and I'll jump in there." I am a member of RATS and PARC as well.
All right, well, thank you. Let's see, now we had a latecomer here.
Are you? Dave Stevens, WB4 DES.
All right. So why don't we get to the business part of the meeting? And Ken, well, first of all, before I get to Ken, does anyone have any questions or comments about the minutes that were posted in the newsletter? I want to thank Armand and the other contributors for the good job they do at having good content in that newsletter, because it isn't coming from the press, not this time. Anyway, so I would like to have a motion to approve the minutes.
So
Second.
moved.
And everybody in favor of approving the minutes?
Aye.
The minutes are
Aye.
approved. And now, Ken, would you like to move on to the treasurer's report?
Yeah, treasurer's report. The good news, we started out the month with $20,809.16. We had dues of a whole lot of money. $806 worth of dues came in. And then we had to spend $39.12 for the people that use PayPal. We had Win, who bought the new laptop that you guys are using there. That was $646.58. I had to reimburse Bruce for the webcam, the wireless mics that you're using for $120.68. And then for the new computer, I bought 2 thumb drives for him for $28.60. The one thumb drive is used as a recovery disk for Windows in case the system crashes. So we built that. And then the second one is that if we need to be able to move files in and out of that computer. And then I needed some new ink for the few things that I do actually print for the club, $83.12 for a whole set. So that was $918.18 of worth of expenses. So that took us to $20,696.98. So, and I have only one new member to get voted into the club, Brooke Estes. W4 or I'm sorry, WF4J. He's an extra. So that's the only one I have.
Everyone in favor of Brooke joining the club, say aye.
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 Welcome to the club. All right. Any old business anyone has to bring up? Okay, as far as the new business goes, the sports backers folks reached out to me. They're the ones that do the Monument Avenue 10K and the Richmond Marathon. And some of the other race organizers had told them that they needed amateur radio with their race. They never used amateur radio. They used cell phones. So I met with them and I told them what amateur radio could do. I had a couple of HTs and I demonstrated how to talk to a repeater. And they said they would get back to us if they wanted the club to get involved. Now I would have to, of course, run that by the board. And I personally have never done anything like this, but there are some people who have. I know Steve Crow is one and other people's, and Jim has done it. So if the board, if they want us to do it and the board approves, then we'll set up a committee to do that. The race is coming up in April. I suspect they probably won't be calling on us, but if they do, I'll let y'all know. Let's see here. I think Bruce, I guess you have an education committee report and also some new business.
Yeah, I was going to try and show you here. So let me. It's always fun when the machine you're working on, the browser, of course, wants to update. It's Bing, so Bing, Bing, Bing. So while I,
I can pass on to John. There's a couple of people who talk if you want to talk.
yeah, the problem is, yes, and I think, David, you want to talk too. Dave, you don't want to talk too as well, right?
Okay, so John DeMeo wanted to talk about some ideas that he had.
Thanks, Frank. We were talking the other morning, is that many of you know, the club got a grant last year from ARRL for $1,000 for educational purposes. We used some portion of that, it wasn't a whole lot, to put on the seminar that we put on last year at the railroad station. The terms of the grant say if we don't spend the money, we got to give it back. And I can tell you, as a person who's gotten grants for several nonprofit organizations, the worst thing you can do is give a grant back, because they'll, look at you and say, you can't spend the money if we give it to you. So one of the things I'm going to propose or throw out to the board and to the membership, one of the things that this club, I think, needs to particularly to entice new members in is some equipment, for example, like an antenna analyzer. Somebody gets gets a license, gets a radio, and they want to set up a station, and it's incumbent on one of the Elmas to get out there and show them how to do the coax and all that stuff. If we had an antenna analyzer and Rick, that little gadget that you had got was a little gadget, Rick. Oh, hey, yeah, the spectrum analyzer. Yeah. A couple of things like that. Maybe a good ohm meter and stuff. Yeah, that would be something that we could offer to Len. I know that the club has loaned property in the past, and one of the problems is we lost track of who had it, where it was, and everything. So I'd like to, if the board and the membership would agree to do this, to put maybe $500 or $600 into some basic test equipment that we could loan. I'd like to volunteer to be the as we were calling it this morning, the clerk of the works, to make sure who's got the equipment and get it signed in and out. That's my idea. You want a motion?
We could. I mean, let's see, Steve Bowles is not here, and I guess Mac isn't here, and Dave Robinson. So that's 4. Maybe that's not enough. 1,
You need a
2,
quorum of the board.
5. That would be, we have 5, Ken, if you
we
vote
do have
for it.
5?
Well, we got John, we got Armin, we got Daryl,
Okay,
we got Lauren, we got me. I think that's,
yeah, 6.
okay, so everyone in favor of, you want to make a motion?
$600, that should be enough to get us a good equipment and start.
Anyone want to, we need to,
That's $600. It's loaning equipment.
okay, board members who are present in favor, not favor? So it looks like it's 6 board members in favor, Ken, so that, I guess that carries.
Yep, that carries.
Thank you, John. Dave, did you have some things you wanted to say?
Yeah, Dave Stevens, new to the club, working with Bruce. Opportunity I'd like to give you. Last year, the club went out and did the space station contact, which was quite successful. This year, Hopewell's asked us to come back to the 6th, 7th, and 8th grader March 20th for that week and do a technician's class. So we're in a process of putting that material together. Right now, I'm asking for anybody that's interested to be involved to come out and help in the projects. I can show you. I just put this together this afternoon. Pull it out of my pocket. Little FM radio. Takes about an hour to solder up, so you figure about another 2.5 hours, but it really works. So a good way to show what FM radio is all about by having them do a kit. We've got a couple other projects on there. So right now I'm looking for interest to come out and help with doing these kind of projects. We'll have the radios. If you're interested in teaching, which is another undertaking, let me know. But right now I'm looking for people that want to come out and work with the kids. We're not sure how many are going to sign up. Right now there's only 2, but we're told that come March is when the children will sign up. But this is their intersession where they had 2 weeks off, but they have an opportunity to do different classes, basketball, baseball, and then of course this radio technicians class. So it's really exciting. We hope to at least get 5, 10, maybe 15. But we're going to need volunteers to come out and help show radios. We're going to have HF rigs, PSK 32, FT8, Bill and Judy, which I don't see them here this evening. They're on the line. Hey, Bill and Julie.
Hello.
Yeah, satellite contact. I'll talk to you, but I'm looking forward to hopefully that'll work with you to come out and do the satellite. But it's that type of stuff to work with the children. We'll have the rigs there so to demonstrate the rigs. And through the demonstrations, we're going to be able to show them what the questions are that are on the technician's class license. So I'll be here. I'll be taking names and looking forward to working with several folks. Excellent. Yep. Yeah. And yeah. Right. It's going to be starting March 20th. It's Monday through Friday, testing on the that Friday. So it's a full day. They start at come in about 7:30, start teaching at 8 o'clock, and they go to about 2:30 with a lunch break. No, Monday through, yeah, with Friday being yeah, it's going to be quite a bit of work, but yeah. Well, but that's what I'm saying right now. Yeah, I'm putting together the teaching and there's lots of material. So if you're interested in teaching, we'll work together. Right now, I'm looking for people to come in and help with demonstrating radios with them because we're going to have HTs. What they're going to get is an HT if they pass, a little bit of enticement. They'll walk home with the FM radio. They'll learn about Ohm's law, and we'll have the volt-ohm milliammeter. So we're going to have activities, but at the same time, trying to teach them, what was it, death by PowerPoint? Yeah. So again, I'm not asking you to teach. I'm asking you to come out and help volunteer and be with the kids. And, you know, we all know how to work radios and show them what a clarifier is, because that's a question on the technician class. What is RIT, right? I had to relook that up. So it's that type of thing. It's just to be involved because it's going to be done by demo. Because the questions for technician is basically memorize the frequencies and what's an antenna, right? So let's go do demo it, and we'll have a lot of fun.
Thank you, Dave. Bruce, are you ready to go?
So assuming I can share. All right, so about the last year, we didn't have anybody sign up for the club. A lot of other places are having problems with the transition from pandemic and that sort of thing. So we're set up this year. So you need to tell your friends about coming out to the RARC. This thing takes all the screen stuff away. You come out to the RARC place and look it up. Oh, I should add, by the way, someone had a chat and what was wrong with the focus on the camera. Well, the brand new autofocus camera we bought wouldn't work this evening. So we have the old camera running. In my case, it probably is good not to see all the focus, but. Okay, so.
I think they think that's out of focus too.
Really?
It is a little bit.
Yeah.
Yeah.
No, this is straight off the computer.
Okay.
No, it won't make a difference to you. Well, okay. If you go up, if you go to RARC, RAR Club, you can see this as the schedule. So the tech class, a couple of innovations in the tech class. This came from Ronnie Bolton, who met with all the instructors and talked about things that worked well in the beekeepers thing. So for technician only, you can bring, someone can bring a member of their immediate family, like a child or a spouse, for free. They found that worked well with the beekeepers. They probably wouldn't buy two $22 passes anyway, and it's a way of getting to practice together, particularly good for kids. So we're doing that. That's one innovation. We are going to give them 1 year of free RARC membership.
We don't have a mentors group like they do with the beekeepers yet. We need that. But this is a way of getting them incorporated in the club. I mean, they immediately can come in. So those are the real innovations there. The other thing is, if you were to look carefully at this, you'll see that this first week in May, all the classes end. So the classes run in a different size, different lengths. But we end in that week so that they can immediately go on the next Saturday and take the tests. So we set that up. So that's kind of the changes in the classes. And if I had anything else to say. Oh, yeah. IEEE has a couple of vans called Move vans. And that's full of all kinds of interesting stuff. They send it to disaster areas. It's going to be at the Science Museum Sunday, right after lunch, like 1 to 4 or something like that. So if you want to look at some really interesting technology, you might wander over there Sunday afternoon. There's been a lot of chat on this on the 543 repeater. So I think you're going to see a lot of hams over there this coming Sunday, right? It's going down to VCU on Monday. So, and I think that's all I got.
Any other business issues that anyone wants to bring up? Can I have a motion then to close the business meeting? Second,
Second.
everyone in favor?
Aye.
So we close the business meeting. How about show and tell? Anybody have a new radio, new license, operating experience they want to talk about? No, huh? Anybody try to work the Bouvet de-expedition? No one tried to. All of you probably know what a de-expedition is, but for those who don't know, it's where a group of amateurs from one or more countries goes to a location that that not many hams exist or don't communicate with. And there's actually a list of, I think they're called DXCC countries. There's 340 countries, and they're ranked in order of difficulty, how to contact them. And usually difficulty arises either from accessibility or from political situation. So the most difficult country to get a contact from is North Korea. The second, you can get the, you can make the contact, but you won't live long enough to send out a QSO. And the second most difficult is Bouvet Island. So that's why it's a big deal. And Bouvet Island is in the South Atlantic. It's more than 1,000 miles away from Africa, South America, Antarctica. It's very bad climate. It's very difficult to get to, and hasn't been operated since 2008. So a group of amateurs from Norway went down there. It's extremely dangerous to land there. There's lots of expenses involved. They're there now, and there have been some problems that are pretty typical of de-expeditions. And one of the problems is that most, if not all, of these de-expeditions work split. I guess everyone here probably knows what that means, but what that means is that you receive the DX station on one frequency. Only the DX station transmits on that frequency. And then usually the DX station does what's called listens up. Usually it's about 5 kilohertz, and there's a range that they look at. I think for the Bouvet, it's up to 30 kilohertz for sideband and 15 kilohertz for CW. So all the people calling the DX are spread out over this up frequency. So that gives people who don't have a huge station the ability to compete with the people with the giant stations. But some people don't know how to work split. So any radio that has 2 VFOs can work split. And so it's usually it's a menu command. You set it up so you transmit on one frequency. You can listen on the second frequency, and if your radio has one of those spectrum scopes, you can see where all the stations are. And so that and like everything else in amateur radio, you want to listen first before you transmit. So what happens is that if someone who doesn't know they're working split, they'll transmit on the DX frequency, so no one can hear him. Then the DX police come in and start yelling. So anyway, so I think if people knew how to operate split, that would, if you want to do that, that would help the problem. Anybody else have any comments?
Lots of patience. And lots of patience.
The stations calling the DX spread themselves out. He'll say let's say he's transmitting on 14 200, listening up 5. So that means he's listening from 14,205 up to 1420, something like that. So you can call, it allows the calling stations to space out. It doesn't have anybody, only the DX is transmitting on that one frequency. So you don't have people, the huge stations are piling up, and it just makes it. And right now, from what I understand, they only have 100 watts in a wire antenna. They don't have their amplifiers or beams up. So, but I've also heard they've worked over 5,000 stations. So for people who get a kick out of working the rare countries people compete, they want to work all 340 countries, every mode, every band, blah, 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 blah. And that's one aspect of the hobby. But for people who just hear about this, but just listen first. And also, if you look at the websites on these DXpeditions, it'll tell you that they're operating split, but virtually all of them do. All right. Everybody comfortable, ready to go to sleep? So what I need to do is, yep.
You're going to be putting a PowerPoint. Maybe we ought to move the lectern to the side so everybody can see.
All right. You can't see the screen?
Well, I think if you switch to using this computer down, send your picture.
All right.
Yeah, that's right. You got to go to share. Yeah, you're fine.
All right. So let's see what we do here. Share screen. I guess somebody has to make me the host or something.
No, you got full authority.
So they're looking
Rick,
at
you got full authority.
And we'll then look at the audience.
Look at the audience?
Yeah.
All right. So should I turn on my audio on this one and turn it off on this one?
Whatever you want, you
I
can do
don't
either
care.
way. What's easier?
I just would use this one.
All right, well.
When you deem it. That sounds fine.
Okay, let me turn off my speaker. Any better? No. You are going to mute yourself.
Rick, you're muted.
Thank you.
All right. You hear me now, Ken?
Yeah.
All right. So, what's going on here? Oh, God, somebody's internet came up. In the world.
I thought that was yours.
It could be.
It is yours. You mean Rick's screen says.
All right. Okay. What do y'all see now?
Transmission lines, white screen.
Stop cursing. Is that what you're saying? Go ahead, Jim.
Can we go back to your PowerPoint?
Yeah, try it.
There we go. And we're going to go to full screen, which is that icon right there. Wow.
All right. So where's my button that says next? Oh, here it is.
Just click the,
All right. So I'm going to give my presidential state of the coax address tonight. Now we're going to talk about transmission lines because I think that's one of the most important aspects of amateur radio. If you want all 100 watts of that 100-watt radio you're about to get out. So in amateur radio, there are 3 types of transmission lines that are used: coaxial cable, parallel wire transmission lines, and waveguides. And waveguides are usually used for 1 gigahertz and up. So we won't talk about those. All right, so the transmission line needs to convey the RF energy from your transmitter. And the desirable properties in that regard include low loss, high voltage, and high power transfer. What am I supposed to do now? I'm blocking it. And also the same considerations make your receive signal better. So a lot of things we talk about with regard to transmission also is reciprocal with regard to receiving. So coax is not new. The first time they used it was in 1858 for the transatlantic cables. Talk to me.
How does he function if he doesn't have that?
I can sit over here.
No, we'll just put it to the side.
Yeah, just sit down.
Oh, yeah, you can sit down. Yeah.
Just, you can use it here and,
Let me have my little mouse. You wouldn't believe that Bruce and I practice this, would you? All right. So it went backwards. All right, so coaxial cable is not brand new. It was used a long time ago. But it increased in prominence during the 20s and 30s when telephonic systems were introduced, and particularly after World War II, and particularly with the use of radar. So this thing is going when it's not supposed to go. All right. So, but in the early days of radio, they used parallel transmission lines. And so here's some examples of that. Bruce, you want to hand these out? This one here is what's called window line. And this is one that probably most people use if they want to use a parallel transmission line. It has an impedance of 450 ohms. Ladder line is even wider than that. It usually uses plastic spacers. It's about this wide. The impedance is about 600 ohms. This is some old twin lead that was used back in the days of TV. And you actually can use that for various low power amateur applications. And this is a twist on that where it's got foam in it and insulated. I'm not sure, other than bigger conductor size, what advantage that offered for your TV, but that was also 300 ohms. But the parallel conductors, there is an electromagnetic field that surrounds each conductor, but it only extends a few inches away from the conductors because the current is traveling in the opposite direction, equal and opposite. Yeah. I'll get to that. What you're referring to is the characteristic impedance, and I will talk about that in a minute. So anyway, the currents and voltages in the two conductors of that parallel line go in the opposite direction, equal magnitude, and they tend to cancel out. So it doesn't create anything beyond a few inches away from the transmission line. But, and so probably the greatest advantage of a parallel transmission line is its low loss. And they are balanced transmission lines, and I'll talk a little bit maybe later about what that means. But the problem with parallel transmission lines is you can't put them next to any conductor because it will interfere with it. You can't bury them, you can't bend them, you can't twist them very much. And like coaxial cable, you can bundle that with other conductors. You can't do that with open wire or parallel conductors. And the coaxial cable largely resolve these problems because the entire field is contained within the cable. It doesn't, as it turns out, due to what's called the skin effect, the outer surface of the inner conductor conducts and the inner surface of the outer conductor conducts, but the field stays in the cable. So that's one of the advantages. It doesn't interfere with things around it, so you can put it next to other objects. So you can bend it, twist it a little bit, bury it. Now, as far as burying cable, you have to look for cable that's certified to be buried. Some are, some aren't. It's less susceptible to electric and magnetic fields outside the cable. And as I said before, it doesn't leak too much outside the cable. So cables, most everyone is familiar with what they look like. There's an inner conductor. Here's some examples of cable someone can pass around. These are three different types of cable in descending order of thicknesses: RG8, RG8X, and RG58. And I'll talk a little bit more about what that means. But so there's a center conductor, there is a dielectric insulation, there's a shield, and sometimes there are two shields. And then there's a protective outer jacket that just protects the coax from dirt and weather conditions. It doesn't have any other function. So the parameters for coaxial cable are characteristic impedance, attenuation of a function of length and frequency. In other words, the longer the cable, the more it attenuates, and also the higher the frequency, the more it attenuates. Power handling capacity of the cable, breakdown voltage of the cable, and shield quality. There are tables in the ARRL handbook that have a huge list of all the different kinds of cable, and they list all these parameters. But I find that Ham Radio Outlet and DX Engineering sells a couple kinds, and they spell out some of the parameters. So for most amateurs, there isn't really anything that it's exotic that you need to worry about in terms of your cable. So the characteristic impedance, why is it 50 ohms? Is that random? As it turns out, it's not random. Back in, it is determined by physical properties of the cable. It's determined by the dielectric constant of the insulator, the distance between the conductors and the radii of the inner and outer conductors. And so currently you can get cables in 50, 75, 95 ohms commonly. And you might ask, why is it 50 ohms? Is that random? As it turns out that in 1929, Bell Labs did a study to find out what characteristic impedance of coaxial cable was the best. And they looked at the voltage, attenuation, and power. And the experimentally obtained impedances were different for each of those parameters. They looked at it varied between 30 and 77 ohms. So 50 ohms turned out to be a good compromise value. Now, characteristic impedance, unless you have a very short piece of cable, does not depend on the length of the cable. And in the commonly used amateur frequencies, it does not depend on the frequency. So that's a parameter. It's actually a real number and not an imaginary number like some of the complex impedances. So the power handling capability, breakdown voltage losses depend on the size of the conductors, type of dielectric. A bigger conductor has less loss, but due to the skin effect, sometimes they use braided wires because of it has greater surface area, and resistive losses in the cable depend on the conductor size. So for higher power, you want a bigger conductor. Common types of dielectric are solid polyethylene, polyethylene foam. Some use Teflon. Other exotic kind of cables might use air or helium. Foam cable or foam dielectric has lower loss because it contains more air. And as I said, you can have a foil lining and another shield over that. Outer jackets of cable are made of PVC commonly. There are two types of PVC. PVC-1 is sensitive to ultraviolet radiation, and it causes it breaks down the jacket and the products leak into the braid and center insulation and degrade the cable. That's called contaminating. So if you are buying cable and you want it outside, you want to look for non-contaminating cable. PVC-2 is better for outdoor applications. And other things that happen, of course, are oxidation and squirrels will bite them. Coaxial cable is more expensive. The bigger the cable and the better the cable, it costs more. As I mentioned, there are many brands of coaxial cable. The RG is a military designation. If you look in the radio catalogs, it'll say RG8 type. So it's not necessarily RG8 as defined by the military, and they may not exactly correspond to military specifications. I think RG 213 is comparable to RG8. So RG 58 is small in diameter, is less expensive. That's the smallest one you have there. RG8 is larger, and the RG8X is intermediate between those two in size and expense. So cable loss is specified in dB per 100 feet. And note that that specification refers only to a matched condition. It only refers to a condition where you have a 50 ohm load. The dielectric losses, those losses increase dramatically with a high SWR. I'll show you some pictures of that. Also, the dielectric loss increases with frequency. So the manufacturers will show you frequency-based information for their cables. Breakdown voltage, power handling relates to how much heating can be tolerated. If you heat the center conductor up too much, it'll cause it'll melt the insulator, and it can cause migration of the insulator. And so some cables will specify a bending radius. So you don't want to bend it too much and heat it up. Otherwise, it'll change the characteristic impedance. So good cables should have 95 to 97% shielding. In the catalogs, they specify how much shielding they have. And if, unlike that piece of RG58 I sent around, you shouldn't be able to see the insulation through the shield easily. So for amateur frequencies below 10 megahertz, RG58 will tolerate full amateur power and might be acceptable for fairly short runs, maybe up to 100 feet. If you're going to operate above 10 megahertz or a longer run, you should consider more expensive cable, particularly if your load is not matched. And one thing that some people may not understand is the SWR that you measure at your radio is different from the SWR you you would measure at the antenna. And the reason for that is the forward power, but by the time it gets to the antenna, is diminished by the loss. And then the reflected is also diminished by the loss. So you get a deceptively low SWR if you have lossy cable. So that can fool you. So if you run 250 feet of RG58 to a non-resident antenna, you may think you have good SWR, but you don't. So ideally, it should be measured at the antenna. RG8 or 213 can withstand full amateur power through the VHF spectrum, but you have to be careful about connectors when you at the higher frequencies. When you get to VHF and UHF, loss becomes critical, and so you want to minimize the length of the cable and use the best quality cable you can get. And keep in mind that cable losses not only decrease transmitted power, but also receive power. So SWR we've talked about, and we'll talk about that more, but the ideal situation consists of a generator, a transmitter, a transmission line, and a load that all have the same characteristic impedance. If that's the case, you don't get any reflected power. All the power will be delivered to the load minus the specified cable attenuation. If the antenna is non-resonant, then only a portion of the power will be delivered to the antenna and the rest will be reflected back toward the transmitter. And some of it gets reflected again at the transmitter, but some of it goes into the transmitter and interacts with the components in there, including the power transmitter. And so if the SWR reflected power gets up to be too much, it can damage the output transistor. So that's why a lot of these radios will fold back their output when the SWR gets above 3:1. And each time a wave travels through that coax and it bounces back and forth, it gets attenuated. So eventually it goes to 0. So SWR, there's lots of formulas for that. People talk about voltage, SDR, so on, but it's a ratio of reflected power to forward power. And the higher the SWR, the worse it is, the more reflected power. Another parameter that some of these devices use is return loss. And the higher the absolute value of that, the better, meaning that you don't get much, you lose a lot coming back because it's not reflected. That's why it's called return loss. So here's a picture that refers to RG8 transmission line. And as you see, when it gets up to an SWR of 10, the space between the red line and the blue line is the intrinsic loss of the cable. That doesn't change as the SWR goes up. So that space stays the same, but the red line gets higher and higher, so that when you get the blue line and the red line get higher and higher, but when you get to an SWR of 10, you have a 3 dB loss, so half your power is lost. And here's another chart that just shows the reflected power. So, sometimes people say SWR of 2 or 3 is not all that bad. At SWR 3, you get 25% reflected power. Much above that, you can see the number goes way up. So a lot of people try to solve the problem of SWR with an antenna tuner. That's really a misnomer. It does not tune the antenna. I think it should be called a radio pacifier, because by using a combination of inductors and capacitors, it counteracts the reactance in the antenna system, which includes the antenna and the cable, but it makes your radio happy, but it otherwise does not decrease the loss in the antenna system, or increase radiated power, or increase the received signal. So the losses are going to be the same. Your output is still going to be bad. The received signal is still going to be not as good, but the radio won't shut down. So cable, if it's outside, it will deteriorate. And most commonly, water gets in at the connectors and it causes corrosion of the shield. And when that happens, it dramatically increases losses. So now some cable, as I said, is meant to be buried, and some cable, the non-contaminating cable is more resistant to ultraviolet light. Some experts say you should check your outdoor cable about every 2 years. And there are a number of ways you can do that. One way is if you either have an open cable or a shorted cable, it should have a high SWR that goes up with frequency. If you have a low SWR with an open or shorted antenna, there's a problem. There's probably other ways to do it. Well, what about parallel transmission line? When should you use that? Like coaxial cable, it has a characteristic impedance. It's determined by the conductor diameter, conductor spacing, and the dielectric, and it typically varies between 200 and 800 ohms. The window line, I passed one there, I think is one of the most popular types, and it has lower loss than coaxial cable because of lower dielectric loss. So one situation, hams want to try to have a multi-band antenna, and that can be difficult. But one way you can do that is feed a dipole at the center with window line, and you can operate on the harmonics. Now, at the resonant frequency, the impedance is going to be 50 to 75, but on the odd multiple, it's going to be high. But because, and that will create a high SWR situation, but because the parallel wire transmission line has low loss, it'll tolerate that SWR. But you need a balanced antenna at the transmitter end. And also you can use a balanced line to feed a full wave loop. Do you need a balun? What a balun is a device that converts an unbalanced condition to a balanced condition. And I did a lot of reading to try to figure out what it means. What does it mean? So for parallel wire transmission line, the current is equal and opposite in both conductors at all places along the line. That is also true for coaxial cable. What is not true for coaxial cable is that the voltage is the same in the two conductors at all points along the line. The conductors in a parallel transmission line are not referenced to any external source. The shield in the coaxial cable is referenced to ground. So a balun, there's two types of balun. There's a current balun, a voltage balun. A voltage balun, when hooked to a dipole, causes equal current to flow in each arm of the dipole, and that minimizes what's called common mode current. What common mode current is a current flowing in a conductor that's not balanced by a nearby opposite and equal current. Now, inside the coaxial cable and a parallel transmission line operate in what's called differential mode because they're equal and opposite. But that's the common mode is not balanced out by a close by current going in the opposite direction. They tend to couple to other things nearby. They tend to seek a low impedance pathway. So when you feed a balanced antenna with coax, you will get common mode current on the outer shield. And this, damn it. So potential problems with common mode current on the coax is it may cause it to radiate, which can interfere with your radiation pattern of the antenna. Also, it can get back into your shack and cause RF interference and even RF burns. And in addition to the balanced and unbalanced situation, if your cable is in the near field of your antenna, it can also get a common mode current on the shield, which is why they tell you to run your cable perpendicular or 90 degrees to the antenna. And also external noise can cause common mode current. Now, another way to deal with common mode current is put a bunch of ferrite beads along your coax, and that creates a high impedance path for the common mode, so it shuts it down. Now, if you don't care about your antenna pattern and you're not getting RF feedback, you don't necessarily have to use the balun, and sometimes the use of them creates problems. So it's not, I wouldn't say required. Union is a different animal. It's an impedance transformer between two unbalanced lines. And the common ones are for a random wire antenna, which uses a 9-to-1 impedance ratio, assuming that the impedance of the random wire is going to be around 400, 500 ohms. And so you want to get that down to around 50. And you have to be careful when using an antenna like that, that it's not resonant on any frequency. And there's a table that lists all those. The other setting where unions are used is with in-fed half-wave antennas, because the impedance of a half-wave antenna increases the further you are from the center. Out toward the end, it's 2,500, 3,000 ohms. So those use a 49-to-1 impedance ratio to make the transformation down to around 50 ohms. Now note that the transformation ratio is the square of the turns ratio. So if your turns ratio is 3-to-1, the transformation ratio is going to be 9-to-1. There's a lot of complexity involved in winding these coils and so on. So key takeaways. I think it's best to use a resonant antenna whenever you can to minimize transmission line losses. You should not go cheap on coaxial cable. Don't buy unmarked cable at the Hamfest. And this is particularly true above 10 megahertz and at VHF and UHF. If you need to use an antenna tuner, you really should put it as close to the antenna as possible. What was your name again? David was telling me that he got a remote antenna tuner, and that will actually tune. If it's near the antenna, it's going to be do more to tune the antenna. It's not just making the, and so the losses, you have the tuner at the antenna, you're not going to have any losses because it's going to be matched going from the, right. But a remote antenna tuner actually does tune the antenna. And remember that the measured SWR is going to be lower in your shack than it is at the antenna. And the I guess you could use, a lot of these radios have built-in antenna tuners, and they generally work with a 3-to-1 SWR. They're not really, and so that's probably okay if you want to tune it up a little bit. So that would be a legitimate use for those. And parallel lines have low losses and may be useful in certain circumstances, as we talked about above. Oh, that's it. So, any questions? Okay, pass out the test, Bruce.
Rick, I have one question.
Okay, go ahead.
If I have an SWR where my radio is going to shut down, the antenna tuner actually would then allow me to run a higher power, even though I have loss.
Yes, but well, only because it's not shutting down.
Right.
I mean, you are running a higher power, but it's still lossy from the output of the tuner to your antenna.
Yeah, but I'm saying
yes, you would be able to run more power, but only because of a quirk of the radio.
Yeah. Well, I'm just thinking if I want to put out 100 watts and the radio says no, with this SRW, I got to go down to 50 or 25.
Well,
the tuner would
it's not a good situation. Yes, you could use more power that way, but the better way is to use a resonant antenna.
Oh yeah.
And that's particularly true at QRP.
Could you explain the difference between waveguide and coax?
We weren't talking about waveguides tonight. I don't know. I'm not a microwave guy, but when you get to microwave frequencies, it's more like plumbing, and they're actually like tubing and things like that guide the microwaves. And microwaves, they want to put if you look at some of these people who do microwaves, the radio is right there by the dish. And that new what's it called, the 905 that ICOM is putting out that goes up to 10 gigahertz, they mount it right up on the dish. But I think a waveguide is more like plumbing than it is. Any else want to expand on that, Gene?
Well, at one time, to the defunct channel 63 television here, which was sold out and later became 65, they ran waveguides some 1,100 feet or something up to the antenna. Apparently, it was much more efficient.
It certainly would be more so than coaxial cable, but you're getting beyond my limited knowledge to talk about that.
You're talking, 20, 30, 40, 50 kilowatts of power.
Now, some coaxial cable in commercial broadcasting can be huge, be this big.
I know I've used it in broadcast, 3.5.
The other thing I
air
read
is 3.5 air dielectric is quite typical in FM broadcast. In AM, one time we ran, if you can imagine the shape of a horseshoe, and you had a wire at the top two sides of the horseshoe and the bottom two sides, and then an insulator in the middle that held a wire in the exact center. You can imagine that as being a coax because you're surrounded, with your 4 outer conductors and the center conductor being your feed line. we ran that on 790 kilohertz for many, many years until the thieves started stealing the copper. So then we put in underground sealed heliacs. But so there's a lot of variations in coax depending upon the situation at hand.
Right, I'm just hitting the comments up. All right, any other questions, comments? No? Oh, my goodness. All right, go ahead.
Otherwise people can't hear on the. One thing, if you're using a window line or a parallel conductor line, on some bands, you'll find that the length of the transmission line, if you adjust that a little bit longer or shorter, you'll make it a little bit easier for your antenna tuner to load up. Than if it's just happens to be some miscellaneous length that reaches from the antenna to the shack. It might or might not work on all the bands that you hope it will work on. And I found that out the hard way.
Yeah, funny things happen at half wave and quarter wave. A half wave reflects exactly what's happening at the antenna. And there's a complicated formula, but a quarter wave does not. It's something completely different. So you have to be mindful. That's only for one frequency, but be mindful with open wires if you're using an exact half wave or exact quarter wave, because that can cause problems. Yeah, I had the formula in here, but I forgot. But it talks about what that is. Yep.
Though you might be interested, our remote station, which is kind of up here, has a 94-foot long wire antenna that runs kind of across the rooftops over here. And then we have a special tuner that tunes for that. And it kind of brings everything up pretty well. But that 94 feet is, you look up a formula and see, okay, what's a non-resident length that you can use for that? So you had to go out and do that formula for 94 feet. And you can make shorter ones that don't propagate quite so well. But anyway, and we do pretty well with the one up here. So
Thanks, Bruce. All right. Everybody asleep yet? No. All right. Anybody else have anything? All right. We're done then, I guess. Thanks
I
for
do.
coming. Go ahead.
Okay, so I had a quick question. Several times it was mentioned that the SWR is better off to be checked at the antenna. Is that an issue with shorter runs of coax, such as a mobile application or portable setup where you've only got, like, say 15 to 25 feet of maybe RG8X or something like that? Is there a significant difference there?
You know, I can't tell you empirically, but I think probably not as much in that situation. Yeah, the situation where you run more coax than you need to, and you have lossy coax, that's where you can get fooled. When I first got into amateur radio, I had a piece of RG8 that I had been using for CB radio, and I had it outside, and it was completely discolored and probably completely contaminated. And I hooked it up to a 2-meter antenna and got a good SWR, but it didn't send out a signal. So that was totally destroyed. But no, I would say for short runs of coax, like you indicated there, it probably doesn't make that much of a difference. But even there, you could use a shorter piece of coax to measure the SWR near the antenna.
Right. Okay. And then what about the difference between an actual SWR meter versus an antenna analyzer?
Well, it's kind of SWR measurement is part of what an antenna analyzer does. It measures the SWR. It can measure complex impedance and things like that. It can measure SWR bandwidth. So SWR is just one of the parameters that an antenna analyzer measures. There can be half a dozen. Did somebody else have a comment? Any other questions? You can do anything you want, my friend.
All right, so if you're desk guard in the field tomorrow, join us at the Powhatan Area Radio Club breakfast. We're at County Seat Restaurant. We get there at 8 o'clock. We have breakfast, and about 9 o'clock, 9:15, we're all gonna make our way over to the Powhatan State Park, and we're gonna play POTA. You don't have to be a member of the club to come breakfast. You don't have to be a member of the club to come play POTA. We'd love to have you. And until we get together again, look February the 18th, which will be a Saturday week coming. The Page County Amateur Radio Club is going to have a mini ham fest over in Elkton, Virginia. The downside is it starts at 7 a.m. They're going to run till about 2. So if you really are super flea market hunter, you're going to be leaving at about dark 30 from here. But there's some other things coming up in March and April. So next time we get together, I'll let that head out.
I wanted to ask, how was Winter Field Day for those who participated? I think Bill and Judy.
We
Was it
had a
fun? Did you have-
blast. It was a lot of fun.
Good.
We had few slight mistakes and things that we worked around, but being the first time out at Pocahontas State Park, it was a lot of fun.
Good. I'm glad y'all enjoyed it. All right. Anything else? All right.
Hey, we have the Berryville coming up in August, don't we? Berryville Ham Fest.
Oh, okay.
And no Frost Fest this year.
I'm going to Dayton this year in May. I've already got okay, I'm going to Dayton this year in May. I've already got a hotel arrangement. I need help driving. I live in Louisa, so I think it'd be like 7, maybe 8 hours, trip. Yeah, somewhere around in there. And it's more fun if you don't go by yourself. So if anybody's interested in going to Dayton, let me know. And we'll figure it all out, where to get together and all that.
Good, I think. All right, we're done.